Ladies and gentlemen and fellow technology enthusiasts, welcome to our keynote titled From Async API to a Deployed Topology via GitOps. In this session, we will explore how Async API, the open source initiative for defining and documenting event-driven APIs, can serve as a catalyst in our quest to design and implement robust event streaming systems. But first, let me introduce ourselves. My name is Markus and I work on cloud native technologies more than 7 years now and started focusing on event streaming and Pulsar about 3 years ago, where I implemented our first event-driven business service based on Pulsar functions. My actual responsibility is to foster technology within our bank and providing platforms and tool stacks to enable our internal DevOps teams. Now, without further ado, I would like to hand over the stage to Armin.
My name is Armin and I am working in Raiffeisen Bank International as a solution architect. First, let's chat about Raiffeisen Bank International itself. We are a top European bank with focus in digital transformation, sustainability, and most important, customer experience. Raiffeisen was founded in 1927 and we are a corporate and retail banking group in Central and Eastern Europe. With 13 countries under our belt, we help over 60 million customers with all kinds of financial services. One of our focus points is digitalization. We are heavily investing in new technologies and better IT systems to make everything run smoother, safer, and more user-friendly for our customers. One example is our Neuron event streaming platform based on Apache Pulsar. This platform is one central backbone for all our data integration initiatives and the foundation for building new, reactive, event-driven applications. This platform plays a central role in our digitalization journey, but also helps to ease the way of working for our IT engineers. RBI isn't just about going digital, we are also super committed of being green. We stand for responsible banking, backing renewable energy projects, and supporting eco-friendly finance. So we are not just looking out for our customers and employees, but also for the planet. In a nutshell, RBI is a European bank that's really embracing the future with our digital and customer experience efforts. So now let's jump from RBI into our event streaming platform, the challenges we are focusing, and how Async API helps us in this journey. Async API aims to redefine the standards for event API description and simplifies the complexities of event-driven communication. Let's explore the comprehensive benefits that comes with using Async API. First, enhanced collaboration. Crystal clear and well-structured API documentation fosters synergies and collaboration among team members. Everyone can easily understand the APIs, resulting in more effective teamwork and problem solving. Second, accelerated development. With Async API, we can auto-generate code and documentation like a pro. This speeds up the development process, allowing developers to focus on building innovative features and functionalities. Third, consistent quality. Async API ensures consistency across all aspects of our projects. Its built-in testing tools help maintain high-quality standards, resulting in flawless and reliable solutions. Fourth, future-proof design. By standardizing event-driven communication, Async API makes our project more adaptable to future changes and improvements in technology, ensuring our long-term success. Fifth, streamlined integration. Async API simplifies the integration process for various services and components, make it easier to build and maintain our complex systems. Next, improved developer experience. Developers can quickly grasp the complexity of event-driven communication with Async API's comprehensive documentation, leading to a more enjoyable and productive development experience. Open source and community driven. Async API is open source and backed by an active community of developers and enthusiasts, ensuring continuous updates, improvement, and support. In conclusion, Async API is for us a game-changing tool that is revolutionizing the way developers approach event-driven communication by offering a wide range of benefits. Async API streamlines collaboration, accelerates development, and guarantees quality, making it an essential tool for our application development teams. With that, let's take a deeper look on how we leverage all the advantages of Async API specifications for event-driven applications and communications. To really gain all the benefits, we had to combine different building blocks and methodologies. It's about the power of declarative approach, GitOps and Kubernetes operators for Async API deployment. Let's check out the benefits of this amazing trio, declarative approach. By defining the desired state of your system, you can reduce errors and simplify maintenance. This approach makes it easier to manage complex systems and ensure consistency throughout your development. GitOps. This method brings the power of Git to your operations. With GitOps, you can track changes, collaborate with your teams more effectively, and roll back to previous versions when needed. It's like having a safety net for your deployments. Kubernetes operators. These handy tools automate complex tasks and application management, making life as a developer much easier. Kubernetes operators work like magic, taking care of the heavy lifting behind the scenes. Also very important, scalability and resilience. Combining these techniques ensures that your infrastructure remains stable and can recover quickly from any issue. You will be able to scale your applications with ease and enjoy peace of mind knowing that your system is resilient. Enhanced security, also very important for us being a bank. By enforcing policies and automating updates, you will be able to keep your Async API deployment secure and up to date. This means fewer vulnerabilities and a safer environment for your application, and that for us as a bank is again very important. In a nutshell, combining the declarative approach, GitOps and Kubernetes operators for Async API development is a powerful strategy that offers a lot of benefits. By leveraging these methods, we have a more efficient, scalable, and secure deployment process. So let's give it a try and see the difference it makes. And with that, I want to hand over to Markus.
Thank you, Armin. For all of you that are new to Async API, let's have a quick look what all this fuss is about. In a nutshell, Async API is an API for event-based services, like OpenAPI for RESTful ones. Besides having the actual API specified, you gain additional benefits. Async API can standardize the design and documentation approach across the services in your company. The documentation that is available is comprehensive, easy to read by people, and foster cross-team communication. The Async API can be used as a basis to generate artifacts. And as always for open source community-driven projects, you can build on existing implementations and contribute back. From theory to praxis. On the left side, you see a concrete API specification. It's based on a YAML text file and consists of several key sections I will show in the demo later. With this Async API, we directly get the service and API documentation. We can include and render this nicely within internal developer portals for easy access from the DevOps teams, including business people. But also you can take the YAML file and render it externally on the Async API Studio webpage. That's also a very nice entry point for a first evaluation. With generators, we can now do much more. We can generate the full Pulsar topology as pipeline instructions that can be picked up and deployed later. This also includes JSON and Afro schema definitions for the pipeline, but also can be used directly in client services. The programming models that correlate with the schemas can be automatically created and updated. These are the Java or Python classes you import in your code. Last but not least, it always bothersome to maintain fixtures for test cases separately. Async API unifies that endeavor by having all example data directly in place, and that can generate fixtures later on. Because we in ABI work with GitOps, all these artifacts are stored in the application's repository. But wait, what is GitOps? It's another buzzword you probably heard about. The basic idea is to store everything in a code repository and using this as single source of truth. For us, this involves the actual source code, configuration, infrastructure, secrets, but now also the documentation. By leveraging Git's version control capabilities, we have seen that GitOps promotes collaboration, traceability, and consistency. And at the end of the day, we have improved reliability and the security of our deployed systems. We also achieved to define our pipeline declarative. That means that instead you tell the pipeline, first deploy tenant, then a namespace, and after that the topic, you state directly how the final topology should look like. For us, that is reality by running everything on Kubernetes with our internal Pulsar event streaming platform called Neuron. How does this work? Our CI/CD pipeline detects any change on the Git repository. A change in the Async API triggers a GitHub workflow that runs all the generators as part of continuous integration. If the topology definitions stored as Kubernetes custom resources change, the continuous deployment pipeline will pick that up and deploy the new target state to the cluster. This is achieved by using Argo CD. Now the resource changed on the cluster, and that's triggering our custom built Neuron operator that will interpret the change, communicate with the Pulsar API, and make sure that desired state equals the actual state in Pulsar. To be able to show you all of the discussed topics now in action, we created a small demo service for foreign exchange rates. We started with the Async API definition, ran the pipelines and written a small Python producer. This generates the exchange rate for currency pairs and published the new or updated exchange rate as an event. But look for yourself. This is how this service looks in our internal development portal. We see that it provides an API, so let's have a look. There it's documented that the service has consumers, and everything you see here is visualized out of Git. Also, this nice view is automatically generated. When we look at the detailed definition that is based on the YAML I described before, we will see separate sections that makes the Async API so relevant. So let's start with the top one, where we describe the service itself. The next section describes the infrastructure component in more detail, so where the service is deployed to. In the operations, we really can have a look on our data. So first of all, the topic, the operation, so we consume exchange rate, and then the actual message description itself with the payload, base currency, target currency, and rates, our business values, and some technical headers. We know about the standard Pulsar one, but we also force the teams to add some custom ones. As described, we also have examples there that can be very nicely used to create fixtures for test cases later on. And also these examples consist of the message payloads and the header. One nice trick is that you can extend the Async API with custom attributes. Here we have a partition attribute where we've defined 2 partitions for the topic. Now let's jump to the source, so the Git repo itself. Let's start by having a look on the GitHub action, the workflow that does all this magic. When the Async API definition is changed, we call a reusable workflow that is defined in our Async API generator. It can generate Helm templates, customized templates, Python models, Afro schemas, and a lot of more things. It's easy to extend. The second interesting folder is of course the Async API itself. Here we see again the YAML in its raw format. When we look now at the deployment folder, there is where things start to get interesting. We have the full topology for the pipeline rendered here in different files. Let's have a look at the schema. Here we see our business values that are picked up by the so-called neuron operator. The neuron operator is a Kubernetes operator that handles tenant, namespace, topic, and schemas. Last but not least, let's have a look at the source folder where we also store the models. Also the models PI file is auto-generated by the GitHub action generator. So that's the version of the service that are currently deployed on our cluster. So let's switch to Visual Studio and actually run the actual version. What we do here, we just import the model you've seen before and have a basic producer with this model in place. So when we start producing, we see our version produces base currency, target currency, and of course the rate itself. But some important thing is missing. From a business point of view, you want to know when the rate is actually effective, right? So what we need to do is to add the new business key effective date, because we really start from the documentation that's just edited in the Async API definition. Also giving meaningful examples directly to have a full updated documentation in place. But what happens now if we push this change to our Git repository? We will see that this push and the change of the YAML file itself triggered a GitHub action. So let's have a look. The action is queued and will start immediately after we have a free runner in place, and now it's executed. It's in progress. So this workflow I showed before does several things. Not only calls the Async API generator, but also links our Async API document. This is really important because you want to make sure there are no syntactic errors in this file. So now it's already done. And what happened now? The generator generated, first of all, new models. Because we added the effective date, we should see this new variable also in the class file, and it's here. Secondly, of course, it needed to update the schema definition for our pipeline. So that's stored in the deployment folder. And these definitions are stored in the deployment folder. So let's have a look at the schema file again. And we've seen the effective date added here. Because we're working in a GitOps way, what happened in the background is that the operator picked up the newly deployed custom resource file. That happened a few seconds ago. The neuron schema, so the custom resource, was picked up, updated, and put via RESTful Pulsar API to our Pulsar clusters. So now it's time to adapt the service, but first let's pull the changes from the Git repo. The only thing left to do is to add the effective date to our little Python producer code. And when we run the service again, via the newly imported models based on the schema on the clusters, we see the effective date published as part of the message now. So to sum it up, by going document first, we just needed to alter our Async API definition. We got the documentation and also the new examples in place. This triggered the pipeline automatically and updated everything in the Git repo. The only thing to change was to adapt the Python code of the service itself. Now let's summarize the key takeaways from our presentation. First and foremost, the adoption of Async API has significantly enhanced the service quality and transparency in our organization. By adopting a document-first approach, we have been able to streamline communication and collaboration between teams, ultimately leading to a more efficient and effective service delivery. Second, integrating pipelines and development workflows have proven to be a crucial factor in increasing the acceptance among our DevOps teams. Only after automation was in place that helped to reduce manual efforts, teams started to onboard the new processes and recognized their values. However, it's important to mention the challenges we face as we scale our event-based use cases. Dealing with enterprise-wide topologies can be particularly challenging and requires us to think carefully about how we design and implement our systems to ensure they can scale effectively. Lastly, the implementation of GitOps principles and declarative definitions like the Pulsar topology Kubernetes operator I've shown had a profound impact on our organization. Not only has this approach resulted in improved service resilience and availability, but it also significantly enhanced our ability to meet the stringent audit and regulatory requirements we face as a bank. This has allowed us to maintain the highest standards of security and compliance while continuing to innovate and grow.
If you're interested in more details, please check out our GitHub organization.